All right, the senior math challenge from 2016 then, and let's do this. I mean, you can just do a column multiplication for this times this, and you get this. So there's one of them. I couldn't be bothered to think through this intelligently, so I literally just did that. Um, of course, when you get to about here, you notice that everything ends up being an 8 because of that whole thing about when you times by 9, the units digit decreases by 1, but you're always carrying a 1 and then a 2 and then a 3 over every single time, so it just ends up all evening out. But anyway, it's not that interesting. I don't know what the point of the question was. Next one, 10% more than normal, so that's times 1.1, and then 10% less is times by 0.9. So if you bought a book on Monday for this, then the normal price times 1.1 equals 5.5. Of course, we can just do 55 divided by 11 here to get the normal price is 5. And then on Friday, well, that's the decrease of 10%. So decrease that by 10%, and you should end up with 4.5, right? Shouldn't be too tricky. This circle rolls around this square. Now, the circle has radius 1, which means it's 1 away from the edge here. And then when it gets to the top, it's 1 away from the edge this way as well, just like it is this way. So if it has a distance of 5 for the entire box, and it's 1 away here and 1 away here, then it's only traveling 3 for this little route here. But then as soon as it hits the top here, it immediately turns and goes the other way, which means it's going to also carry over 3 this way because it's going to be 1 short of that edge as well, just like it's 1 short of this edge. And you just go around in a box 3 by 3 by 3 by 3. So you travel a distance of 12 in total. Scaling triangle, one of the angles is 80, so there are 100 degrees left over across the two angles. If the difference between the other two angles was 0, then they would both be 50, and then it's an isosceles triangle, not scaling. If they were both 60, if they had a difference of 60, they have to add up to 100, so it would be 80 and 20, but then you'd have two angles of 20 because of the original one. If they have a difference of 80, that means 90 and 10, and then your triangles, the angles go 10, 80, 90, so that's scaling, and we'll accept it. With these digits, the first thing I thought that was square was 256. It's just kind of helpful that if you just know a lot of things or are very quick to, because you don't want to sit here squaring things to try and list out all the square numbers that are 3 digits, right? So 256 was the first thing I tried, which means that the other number, regardless of whether you put it vertically or horizontally, the other number has to have the digits 3 and what is the other one missing? 4, and has to have a middle number of 5. So it's either 354 or 453. Sorry, that should say 453, like I said out loud. Apologies. Now, neither of those are prime, even if this one was correct. Neither of them are prime. So I started again and went, okay, well, what's the next square number I can think of that uses these digits? And wasn't too hard to come up with 324. I know that's 18 squared. So 324 is the next one. I just decided to try, put that in there. The other digits left are 5 and 6. So it's either 526 or 625. And 625 immediately triggers my mind. That's definitely 25 squared. So I'll go with a 2 in the middle, and that will, I think, work out. Good. I think this is about similar shapes then. The length of BC is 3, and the length of of BE is 4, which means this little length here is 1, right? So what I did here, as I said, the area of this big triangle here, ABE, is a half times 4 times 3, which is 6. Now, that means that the grey area, this triangle down here at the corner is just a similar triangle to the ABE triangle, and its scale factor is a quarter, except its scale factor across length is a quarter, right? Because it goes from base 1 to base 4, which means its scale factor across area is a quarter squared. So I think the grey area is 6, which is the whole area, minus this area, this triangle's area, which is 6 times a quarter squared, because the scale factor is a quarter and we square it. So this is just representing the area of the little triangle, 6 times the scale factor squared, and this is just the big triangle. If we take them away, we get the whole thing. Of course, that makes 3/8. 6 minus 3/8 is 5 and 5/8, I guess, for our answer. That's 1 over 2016, which is quite small. That's 1 over 2016 rooted. Now, root 2016 is less than 2016, so we're dividing by a smaller number here, which makes the number bigger. So this is the smaller one so far. That's just 1, so it's not even close. That's, yeah, okay, cool. So the answer is 8, obviously, because it's 1 over something, which is going to be much smaller than the others. How many squares are formed when n equals 7? So what you notice is that when n equals 4, if you just look at this kind of quadrant up here, the number of grey triangles you get is 1 plus 2 plus 3, and then you times it by 4 to get all 4 quadrants. So if we have n is 7 at the top, it's just going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6. And that's how many triangles are just going to be in each quadrant. So we work that out, which is 21, and then we times by 4, and I think we end up with 84 little squares in our box. This is just the question where you just test all of the points. So if we look at this one here, does it go through 0, 0? Well, no, because 0 squared plus 0 squared is not 1. Does it go through 1, 0? Yep, because 1 squared plus 0 squared is 1. Likewise, it must go through this one, and then it doesn't do this one. So this does 2 of them. And then I can't be bothered to go through all of them. You just literally have to check all of them against all of them. And it's going to take you a minute, but it's a guaranteed mark as long as you're careful. And you end up with 3 of them going through it, which is fine. So we're going to put the numbers 1 to 9 in this grid here. 12 is a good number to start with here because 12 is quite restrictive. How do we multiply 3 numbers to make 12? Well, it could be 1 times 2 times 6 or 1 times 3 times 4. And I think that's it, as long as we're not allowed to repeat a number. Like I know 2, 2, 3 works, but we can't use 2 2s. So I think that's going to be it. Okay, so either this row goes 1, 2, 6 in some order, or 1, 3, 4, and then vice versa, like this row has got to do the other thing, right? So that means a 1, I think, goes here, because they both have 1s in, so the 1 has to be the shared one. Now, 216 seems to be the next best one to go with, because that's quite big, so you are probably going to be forced to use quite big numbers. I divided it by 9 to find 24, and then said, okay, well, I can use 4 and 6 with a 9, or I can use 3 and 8 with a 9. And I think, again, that is probably going to be just about it to find that number. And then I got a bit stuck and was like, okay, well, what about 112? And actually, 112 ends up being quite useful because it's divisible by 7. So the 7 has to go in this row, which is really useful. It's if you divide by 7, you get 16. So it's either 2, 7, 8. And that's actually it, because you can't use 4, 4, 7. So, okay, well, the 7 has to go over here because it's not part of this row. We know that, and it's not part of this row. So, okay, cool. The 8, well, we need to think carefully about where the 8's going to go. It can't go here because this row can't be 1 times 8 times something, so 8 has to be over there, which makes this row the 3, 8, 9 row, which is cool. Now, the 9 can't go up here because it disrupts this row, so the 9 is down there, and that makes the 3 up here, which makes this row the 4 to make 1, 3, 4, and this the 2 and the 6. And then the missing number that we haven't discussed is 5. Times together these numbers here, and we get 30, I think, in total. Question 11 then, I just did with a load of algebra. There's probably an easier way of doing this, but I never read the solutions that carefully, so I couldn't be bothered to actually find out what it was. I got the answer in the end, so yeah. Now, firstly, I'll call this number y, and this number here is just x plus 25 over 2 because it's the mean of the two next to it, which means I can describe this number in terms of x because I can say this plus this, or divided by 2, equals x. And instead of writing all divided by 2, I just times both sides by 2 immediately to get 2x over here. Then I'll times by 2 again, just to get rid of this divided by 2, and then you can rearrange this for y, and you end up with this here. So that's this box expressed in terms of x. Now again, I can call this box z, and try and express that in terms of x, and I'm just working my way along the line. So z plus x divided by 2 equals y, which I've already described in terms of x. Cancel the divide by 2's, and then just take away x on both sides, you get z as this, which is good, because now 10 plus y, which I have in terms of x, all divided by 2 equals z, which I can write like this, and again, just double all this over here, and then maybe double everything again. It's kind of do your take away 10 first, then double everything again. Then we can very quickly solve this, hopefully. Take away 3x, add in 120, gets you to, I guess, 95. Sure. So we get 95 is 5x, so 19, I guess, will be the answer. And yeah, there's probably easier ways of doing that, but whatever, I got there in the end. What's the smallest square that has 2016 as a factor? Now, we should have done our homework, which means we should know 2016 is this as a product of primes. Now, to make a square thing about this, I think I have a video on this somewhere. It's always a nice little question you can, or number theory question you can give things to do with making numbers into square numbers. Anyway, to make this essentially into a square number, all I need to do is donate it 1, 2, and 1, 7, because then all of the powers will be even. And the reason that's really helpful, I couldn't be bothered to actually times this by 2 and 7, you get some number. But I know this number is a square number because all the powers are even, which means I can write it like this. So it's something squared, which of course I can then work this out, right? 8 times 3 times 7, I think is 168. I think I just did 8 times 21. Is 168 squared. So 168 squared definitely has 2016 as a factor, because if we just work backwards, we'll see that it involves these primes here. So I guess 168 squared will be our answer. Good. Anyway, we have side lengths of 1 and 1, so a geometry question here. This length here is clearly just pi. Sorry, this length here is clearly pi because it's got a radius, it's half of a circle radius 1, so it's 2 pi r, which is 2 pi, but then we divide by 2. So this length here is pi. Now this length here has radius 2, and it's a quarter circle, so that's going to be pi times 2 is 4 pi, but then we quarter it, so that's also going to be pi. So this is pi, and this is pi. This length here is 3 and 3, so 2 times pi times 3 is 6 pi, divided by 4 is 1.5 pi, or 3 over 2 pi, that's this one here. And then finally this one here, that's 3 plus 1 plus 1 is 3 plus 2, which is 5. 2 times pi is 10 pi, divided by 4 is 2.5 pi, and then we add them together, and we end up with 6 pi. Which of the following is a counterexample? If n is not prime, firstly, we need to cross out any options where n is prime, because this is specifically talking about when n is not prime, so b is irrelevant to us, because it says if n is not prime, then n minus 2 is not prime. So this is not prime, n minus 2 is 4, and that's also not prime, so that's not a counterexample, that's just the statement happening. So it's not this. 27 is not prime, 25 is not prime, so again, that's just the statement happening. 33 is not prime because it's 3 times 11, but 31 is, so that is the counterexample to the statement. For this question here, tempting to do something very complicated, but I just sort of try to extend the lines a little bit. So like if I put this line going to there, this angle here to the edge of the rectangle is still 55 because of corresponding angles. Then I went down again. Now this angle here, if I did, sorry, well, I mean this angle here is 65. And now we need to think about this quite carefully. I continued the shape around. Firstly, I'll argue that this is Q, this is 60, this is P, and this is 55. So I'm doing something with exterior angles here. Now this exterior angle, I think I just said was 65 plus R. And I think the reason that I can get away with that is because if you draw a horizontal line across here, this is R, and this would be 65, both being corresponding to this. So imagine a horizontal line being drawn here. You've got an R here, and you've got a 65 here, so this whole thing is 65 plus R. Anyway, that means the exterior angles are just all the angles that are in the picture of this new black shape I've drawn, and they will, of course, add up to 360. So if we just do 360, take away the numbers that we have, which actually average to 60, so it just makes 180, then that's the other 3 letters added together, and we'll have our thing there. 216, again, we should know the prime factorization because it came up a couple of questions ago. So when we root it, I mean, the square numbers in here are clearly a 9 and a 2 to the power 4, which is 16. So 9 times 16 is the square number that's going to come out of here, which is 144. So I think this is root 144, root 14, which is 12 root 14, as a quick way of doing that. 56 is a bit easier. I think that's just 4 times 14. I mean, the 14 is, yeah, if you know this makes a 14. I mean, that's the other way to do this, right? Is you see that this makes a 14. And then you know that this one leaves behind a 14, and you just work out whatever needs it to be. But anyway, this adds to 14 root 14, which is 14 times 14 to the half. 14 to the 1 times 14 to the half is 14 to the 3 over 2. So as a power, it's 3 over 2. 3-digit code for his bike lock. So it's tempting to think this is just going to be product rule. I couldn't really find a nice way of making product rule work here. So what I did was I just tried to look for a pattern. So if you make the first digit 7, the other 2 digits have to be 8 and then 9. So there's only one way to do it if you choose first digit 7. Now, if you choose first digit 6, then second digit could be a 7 or an 8. Can't be a 9 because then you have to go 6, 9, 9, which is not allowed. So it could be a 7 or an 8. And then the last digit could be an 8 or a 9, depending on what you did. So either it's going to be 6, 7, 8, 6, 7, 9, or 6, 8, 9. And there are 3 ways of doing it. And then I counted up one more time for 5, which of course leaves these options. So it's either 5, 6, 7, or 5, 6, 8, or 5, 6, 9. There are 3 ways of doing that. Then 5, 7, 8, 5, 7, 9, 2 ways, 5, 8, 9, 1 way. So can we see, firstly, there's going to be 6 ways, but this is kind of triangular numbers inside of triangular numbers, right? This is UK Math Challenge, so I'm just going to assume that these triangular numbers pattern continues, but I don't really have to make that assumption. Because of the triangular numbers inside of these, the fact that this went 6, 7, 8, 6, 7, sorry, 6, 7, 8, 6, 7, sorry, 5, 6, 7, 5, 6, 8, 5, 6, 9, that's 3 ways, 5, 7, 8, 5, 7, 9, 2 ways, 5, then 1 way for if you start with an 8 in the second digit. Your getting to 6 by doing 1 plus 2 plus 3, right? So you're forming these triangular numbers, which then in themselves make triangular numbers when you work along. So that's the one that starts with a 7, that starts with a 6, that starts with a 5. We can go all the way down to the one that starts with a 1. So it starts 7, 6, 5, 4, 3, 2, and 1. And I think we just need to add these options together, which ends up being 84, which is interesting because we also got 84 from the previous question. I can't remember which number it was, that also involved triangular numbers. So just kind of an interesting tidbit there. Anyway, radius 1 means this. I'm going to draw a triangle like this. And then this angle is clearly 90 because it says that the arcs are split into 4. So that's 90. I think I can work out this segment by doing 90 over 360 times 1 times pi times 1 squared times pi is the area of the sector. And then if I take away this triangle, that's just a half times 1 times 1 because this angle is 90. So it's just base times height times a half. Okay, so this makes a quarter pi minus 1 half, sorry, which I can then times by 1, 2, 3, 4 to get 4 white segments, which makes this. And then the whole area is obviously just pi times 1, which is pi. So let's just do pi minus this, which ends up being 2 as our answer at E. 19 then. So a set of 5 different positive integers, the largest of which is m. We want to be able to not make a quadrilateral out of any of the 4 numbers of those 5, and looking for the smallest value of m possible. Now, if we're looking for the smallest value of m, it makes sense for m to be the biggest and to make all the other numbers, well, m is the biggest, it says so, make all the other numbers as small as possible as well. So let's go with this first. Now, this doesn't work for a couple of reasons. Firstly, m is 9 seems like it might be the answer. The reason for that is because when we draw a quadrilateral like this with sides 2, 3, and 4, this length here can't be bigger than 9 because these sides themselves add up to 9. And this is the shortest route from here to here. So it's kind of like the triangle inequality, whereby if this was like 10 here, this route would be shorter in length than this route, which doesn't make any sense. So m is 9 seems like the answer, except we're allowed to pick any 4 of the things in this set. And these 4 would make a quadrilateral that we could actually draw, right? Because none of these numbers here are big enough to break the triangle inequality with just those 4. So what we need to do is we need to pick the first 3 to be 1, 2, 3, then break the equality immediately. So I'm going to pick the 4th number to be 6, because that way these 4 don't draw a quadrilateral under any circumstances because the 6 is too big. It's just the same as this kind of drawing. And now we can draw the m such that we have a 2, 3, 6, and m has to be 11, has to be less than 11, right, to make this make any sense. So 11 will be our answer that we can go with there, I guess. And yeah, next question. I've blown this picture up. I couldn't really understand why they'd given us the tessellation. Maybe people can enlighten me in the comments as to what's helpful about this, because I don't think it's helpful at all. Based on the numbers in the question, this is 2. This whole thing is 8, which means this is a 3 and a 3. Now, we were looking for the grey area. Tempting to work out 64 minus a bunch of things, but I think that's too much work. Let's draw a square inside this grey area like this. I know it's a square because this is 2 across and there's symmetry everywhere. So it's just 2, 2, 2, 2. So this area is 4 in here. Now we just need the 4 triangles. Now the area of the triangles here, if I know this length is 2, then because this length is 8, again, like we said here, it's just the same. This height is 3, which means the height, because these triangles, I think, look exactly the same to me, the height of each of these triangles must be 1.5. So the area of this triangle is a half times 2 times 1.5. Lots of things cancel, you end up with an area of 6, and there's 4 of them, actually, I should say. So I've done all 4 of them together. So now the answer is just the 6, which represents this area here, plus this 4, which gives me an area of 10 in total. Right, so we have a smaller circle, radius 1, with 10 circles going around it. We're being asked for the radius of the bigger circle. I drew a triangle here, going from center to center of these adjacent circles here. Now that, if I call the radius of the small circles little r, has length 2r. And now I complete the triangle like this. This side and this side have length 1 plus r, so it looks a bit like this. Now this angle here is 36 because there are 10 of these. 360 divided by 10 is 36. Now I'm not really interested in that. I'm going to cut this triangle in half like this and say that this angle is 18, which I can see is probably something that I should be thinking about doing. Now, I think I can work out here that the right angle to this triangle is here. So sine of 18 is this over that, where this is just r because it's half of the 2r, right? So that's sine of 18. I think I can rearrange that in terms of r by just timesing 1 plus r across, moving this to the left, factorizing the r, and then putting it back again. And I think I end up with this. And now that means that the radius of the outer circle is 1 plus 2 little r's. So it's 1 plus 2 lots of that. Times this by 2, obviously there. 1 is the same as 1 minus sine 18 over 1 minus sine 18. And then we just put the numerators together and we end up with this, which is answer number C. Question 22 then is just the one where we test these things. So if Ben is telling the truth, then exactly one of Cam or Dan is telling the truth. Dan says exactly one of the others telling the truth. So let's just pretend Dan is telling the truth. And we can make that consistent by saying that Ben is talking about Dan and Dan is talking about Ben. So they both are telling us that Cam is lying. So Cam is lying, neither Dan, well, yeah, because Dan and Ben, we say, are both telling the truth. So I think Cam is lying, and that's absolutely fine. And we'll underline C, and we'll move on immediately. So the first thing we tried worked. A cuboid has sides this. So if it's containing with a sphere, that means the diagonal length of the cuboid has got to be the diameter of the sphere going around it. So, okay, well, if we do Pythagoras, and you can do triple Pythagoras here, this is just root 22 squared plus 2 squared plus 10 squared. If you want to do Pythagoras in 2 goes, that's fine. But if you ever see a 3D thing like this, you can just do root, you can essentially d squared, which is the diagonal. D squared equals a squared plus b squared plus c squared. It just expands like that. So anyway, we get root 588, which means that the radius is that. Doesn't really matter. We're going to put a cube here, and we want the diagonal to still be that root 588. So we've got 3x squared equals 588 because it's just root 588 all squared. And then this is x squared plus x squared plus x squared is 3x squared. I'm just doing triple Pythagoras again. Divide by 3 and then square root, and we get x is 14 for answer. Just the last two then. So a nice geometry question here that I'm sure they've asked a couple of times before. This length is 1, or at least I'm going to say that it is. This length is 1, which means this is a half and a half. I could have probably said this was 2 to mean that I don't have to work with fractions, but who cares? Now, we need to maybe call this x, which means this length is 1 minus x. And critically, this length is also 1 because it's the radius of this circle here. Now, I think that this is a tangent to this circle, and so is this line here, because it touches this circle as it would go around again. So from that circle theorem, I think this length here, this straight length here, is equal to this straight length here, because they're tangents meeting at a point away from a circle, and likewise for this tangent and this tangent. Now that's super helpful, because if I focus on this triangle now, I think that this is a half, this is x, this length is 1 minus x, and this length is a half. So this whole length here is, I think, 1.5 minus x, just adding those together. So we end up with this. And now we can just do Pythagoras on this triangle here. Expand this bracket out carefully. I think I times by 4 everywhere at some point. The x squared cancel, which are very nice of them. And you end up with x is 2/3. So the ratio of TR, which we think is 2/3, to UR, which is a half, is 2/3 to a half, times over by 6. And you end up with, I think, 4 to 3. N is the smallest number for which 7 times n has 2016 digits. So that number that we're making, 7n, is going to equal 1 with a whole bunch of zeros followed by some single digit at the end. Because 7 is less than 10, that k is going to be less than, well, it's going to be 6 or lower, right? I think we just need to find out what that k is. So there are 2014 zeros in between this number. Like, the reason that we know the number looks like this, of course, is because n is the smallest integer for which this has 2016 digits. So if you make the number starting with a 5 and then having a bunch of random numbers, well, you're nowhere near the smallest 2016 digit number, right? This is the smallest way to make a 2016 digit number, where k is some small number that we just need to try and figure out. So let's do a bus stop and try and divide this number by 7. Now, 7s into 10 go once with 3 left over. I could have put a 0 here, but I couldn't be bothered. And then we keep going, and we end up getting this repeat, because, so you can do this more properly on your own if you want to, but you carry 2, that's a 2 with 6 left over, and then 7 to 60 go, I was doing this in my head, go 8 times with 4 left over, 7 to 40 go 5 with 5 left over, and you keep going until you get to 1 again, and then the whole thing is going to repeat. So there's 6 digits here that are just going to repeat over and over again. Now, how many digits are there to work through? Well, I kind of ignored the first one. So I think there's actually 2015 digits to work through. So if I divide that in groups of these 6, I get 335 groups of the 6 plus 5 left over. So I think the k is going to be the second to last of what we were doing. So it's going to be the one that would usually have got us to a 5. So that means the number carried over was a 4, because then 7s into 40, if this had still just been a 0, would have been 5 with 5 left over. But I don't want this to have any carry. I want it to end the whole thing here and be a multiple of 7. So therefore, I think I need to make k2 to make 42, and then the last digit will be a 6, because 7 and 42 go 6. So I think that's the last digit of, and this number here is n, right? Because it's 7, it's this number divided by 7. So this is the number we're making of n. And I think that last digit of n needs to be a 6, because you'd end up doing 42 divided by 7, which is 6, and you'd end your division there. So I think the last digit of 7 is a 6.